Hi, happy almost Valentine's Day, guys. I have a problem I want you to solve real quick. It looks like this. Let's see. 128 times the square root of e times 980. Now I'll give you the answer at the end of the video. Alright, so we're going to go over the basic exponent rules that you know most of these already, but we're just going to review them today, and then some common powers that I need you to know. Alright, the first rule is the product of powers, and that's when we have a number raised to an exponent times the same base raised to a different exponent. Then we can take that base one time and add the exponents, m plus n. That's the product of powers. For example, if I had 2 cubed times 2 squared. 2 cubed is 2 times 2 times 2. And then we're multiplying this by 2 squared, which is 2 times 2. So that's the same thing as 2 times 2 times 2 times 2 times 2, which is 5 2's, which is 2 to the 5th. Or if we had just added our 3 plus our 2 in the first place, we would have gotten 5. Alright, the next one is the power of a power property, and that says if I have a number raised to a power, and then it's in parentheses, raised to a different power, we multiply those two powers together. So for example, if I had 2 squared, and then I took that as a group and cubed it, that's like saying 2 squared 3 times, because cubing means multiplying something by itself 3 times, which means I have 2 times 2 times 2 times 2 times 2 times 2, which is 6 2's. Or if I'd have just multiplied those together in the first place, we would have had 6 2's. Okay, this next one is the power of a product property. If I have a product, two numbers multiplied together, or 3, or however many, and I raise them to a power, I can distribute that power. So this is the same thing as saying a to the m power times b to the m power. For example, if I had 2 times 3 and I raised it all to the second power, that's the same thing as saying 6 to the second power, which is 36. Or if I follow the power rule, I could say 2 squared times 3 squared, which is 4 times 9, which is 36. Alright, we have the negative exponent property, and that says that any number raised to a negative exponent is the reciprocal of that number raised to the positive of that exponent. So the negative here turns into the reciprocal, and we've talked about that many times, but I want you guys to make sure you remember that. For example, if I had 2 to the negative 2 power, then the negative becomes the reciprocal 1 over 2 to the positive 2 power, which is 1/4. And you could punch that in your calculator and check it if you don't believe me. This next one is the zero exponent power, and we've talked about that also quite a bit. Anything to the 0 power is 1. And you can check it in your calculator. 2 to the 0 is 1, 57 gazillion billion, whatever, I don't know. 573 to the 0 is 1. Anything to the 0 power is 1. Okay, we have the quotient of powers property, and that is if I have a to the m power divided by the same base to a different power, then I can subtract those two powers. For example, if I had 2 cubed over 2 squared, then that's like saying 2 times 2 times 2 on top and 2 times 2 on bottom, and then you can cancel out 2 pairs of 2's, and you have 2 to the 1 power, or 2, left over. Or if you just follow the rule, 2 to the 3 minus 2 is 2 to the 1. It's a lot easier to just remember the rule, but if you do forget it, this method always works just fine. And the last one, we have the power of a quotient. So if I have a quotient, which is a fraction, so a over b or whatever, all raised to a power, we can also, just like we could do the power distributed to multiplication, we can do it to division, a to the m over b to the m. For example, 2/3 squared. That's like doing 2/3 times 2/3, which is the same thing as doing 2 squared over 3 squared. Either way, you get 4/9. So now for a couple of things I want to make sure you know not to do. If I had a sum to a power, you cannot distribute that power across a sum. It only works for a product, multiplication, or a quotient with division. So plus or minus here, it won't work. For example, say I said 2 plus 5 squared. If you told me that you could distribute that 2, then you'd be saying 2 squared plus 5 squared, which is 4 plus 25, which is 29. But 2 plus 5 is 7, and 7 squared is not 29. It doesn't work. Alright, so to practice, we're going to simplify the algebraic expression and write with positive exponents. And that's because in standard form we want positive exponents and not negative ones, which we know what to do with those. Alright, so for this example we have 2x squared y all over z to the third power. Sorry, I forgot to put the third power. So what are we going to do with that? This says that we can distribute to the multiplication and division. So that can be 2 cubed and x to the 2 times 3 and y cubed all over z cubed. So that gives us 8 x to the 6th power y cubed all over z cubed. Alright, next one, we're still simplifying. This time we have multiplication. So what we're going to do is just multiply together the like parts. We're going to do 5 times 3, and we get 15. Then we're going to do x squared times x, and we add the exponents, so we have x to the third. Then we're going to do y to the fourth times y to the negative second. When you add your exponents, 4 plus negative 2 is 2. And then we just have a z, so that just stays out there. And that's really it. That's your simplified version right there. Alright, try to simplify this one. We've got a group to the 5th power and a group to the negative 2nd power. So the first thing I'm going to take care of is distributing these powers. So I've got b to the 5th, and then I have a to the 2 times 5 is 10, and c to the negative 1 times 5 is negative 5. That's that group. And then this group I have b to the 2 times negative 2 is negative 4. A to the negative 2 times negative 2 is positive 4, and then we have c to the negative 2 power. So the first thing we took care of was the exponent. Now we can multiply the like parts together, and when we multiply the like parts together we're just going to add the exponents. So we have b to the 5th times b to the negative 4th. Well, 5 minus 4 is 1, or just b, 1b. Then we can multiply the a to the 10th times the a to the 4th. We're going to add the exponents, and we get a to the 14th. And we'll multiply c to the negative 5th times c to the negative 2nd. Negative 5 plus negative 2 is negative 7. And since the instructions say with positive exponents, we're going to turn this one into the reciprocal. And please note that the negative exponent is only touching the c. So the b and the a to the 14th power stay on top, and then the c to the negative 7th becomes c to the positive 7th on the bottom of the fraction. Alright, here we have one, it's m to the 19th, and n, and p to the negative 8th times q to the 5th, and then all raised to the 0 times mnq. Alright, so this one looks tough, it's ugly, but if you remember that anything raised to the 0 power is 1, and this entire group is being raised to the 0 power, then that entire group just equals 1. So we have 1 times mnq, which is mnq. Okay, one more. A squared b cubed c all over 2abc squared. Note that only the c is squared, not the a or the b or the 2 down here. Alright, so we're going to take care of like parts. We don't have any constants on top, but we have a 2 here on bottom. So we have 1/2. Then we have an a squared on top and an a to the 1 power on the bottom. When you don't see a power, you know it's 1. And 2 minus 1 is 1. So we have a, or you can think about it as there's 2 a's on top, 1 on bottom. One of them are going to cancel, so you've got an a on top basically. Alright, then we have b cubed over b. One of those b's is going to cancel out, or if you think of it as 3 minus 1 is b squared. And then you have c over c squared. So one of those c's is going to cancel out, and you're going to have a c on the bottom. So to make this prettier, we have 1, and then if you think of these over 1, we've got AB squared on top, and we have 2C on bottom. And that is that. Okay, so now back to the problem that we started with on the first page. I said 128 square root of E 980. What does that equal? Oh, I don't know. What does that equal? Well, I could do this. And this. And this. And it equals my Valentine for you guys. Aw, isn't that sweet? Alright, and then this last little bit is some common powers that you should recognize. Now, I didn't say memorize, I said recognize, because you will have your calculator, and you can check these with your calculator, but what I'm hoping is that once you look at these, look at this list, and look at it a few times, I mean, we all know that 4 is 2 squared, and we know that 9 is 3 squared, and when we see 16, hopefully we recognize immediately that that's 4 squared. And 25 is 5 squared. And 36 is 6 squared. Hopefully you all know that 49 is 7 squared. And 81 is 8 squared. Right? Ha, no, 64. 81 is 9 squared. And 100 is 10 squared. How about 11 squared? That's 121. So if you saw a 121, I hope you would recognize that that's a perfect square. Same thing with 144 is 12 squared. And then 169, which is 13 squared. Hopefully when you see any of those numbers, you say, oh yeah, those are perfect squares. I also want you to recognize some perfect cubes. For example, 1 is a perfect cube. It's 1 cubed. And 8 is a perfect cube because that is 2 cubed. I need, especially with the 8s, when you see 8, you should know that that is 2 to the 3rd power. And then you should also hopefully know that 27 is 3 to the 3rd power. This one you might not know, but 64 is 4 to the 3rd power. So when you see 64, just know it's a magic special number, and you can check it out in the calculator if you don't remember what it is. 125 is 5 cubed. And 216 is 6 cubed. 343 is 7 cubed. So I just want you to know that these are special numbers, and hopefully when you see them, you'll recognize them as perfect powers. And then we've got some 4th powers and 5th and 6th that, you know, if they were to show up in a problem, I would hope that you would recognize that 16 is 2 to the 4th, or 81 is 3 to the 4th, because 16 is 4 squared, and 4 is 2 squared. So it's like going 2 times 2 times 2 times 2. And same thing with 81. That's 9 squared, or we could do 3 times 3 times 3 times 3. You could also have 4 to the 4th power, which is 256. So that's the same thing as 16 squared. And then I hope you guys recognize 2 to the 5th power is 32. That's another one that if you see a 32, you should know that automatically. And 3 to the 5th power is 243. And like I said, you don't have to memorize these. I just want you to kind of know the basic ones, because when you have a problem with one of these numbers in it and you're trying to solve with logarithms, it's helpful if you already know that it's a nice, perfect power. That's all. Alright, so have a great Valentine's Day, and I'll see you guys tomorrow.